So again, whatever number's in front of the x squared determines whether it opens up or downward. This one opens up, because, well, I mean, this one would open up if that's positive, and if it were a negative, then it opens downward. So we can determine the vertex by just taking the value in front of the b, dividing it by 2 times a, and then negating it. Then that value goes back into the equation, and then that tells us the vertex. Now with this, finding the x-intercepts is a little bit easier because all you got to do is just solve this by either using the factoring, which doesn't work for all of them, but for some of them it will. And then you can always use the quadratic formula. That one will always work. And then once you have those solutions, that's your x-intercepts. And then your y-intercept, when it's in this form, let me just point out, it's whatever c is. Because if you let x be equal to 0, whatever c is going to be your y-intercept. So we're going to go through one or two of them from scratch in a minute. I'm just kind of going through the incidentals on it. See, that's what they tell you here. The y-intercept is 0, comma, c. All right, let's go through one, and then we'll go through one kind of from scratch. Or we'll go through a couple of them from scratch. All right, so this one is negative x squared plus 4x plus 1. The value in front of the x squared is a negative, so it goes downward, downward, downward. It's hard to do it on this, the way I got this set up. So that's what it's doing. So the vertex is negative b over 2a. So negative, and b is 4. 2 is just 2. And the value in front of the x squared is negative 1. So 4 divided by negative 2. Looks like they made a mistake there. Right? Let me just check it, double check this. I find mistakes in these books all the time. So, but sometimes I might be just wishing I did. Oh, no, it's right, because the extra negative sign out there. So that's right. So 4 divided by negative 4. I'm sorry. So 4 divided by 2 gives us 2. And we got 2 negative signs, so it's positive. All right, so that one's all right. So now that's the vertex. That's what they call the line of symmetry. So now what we got to do is we're going to take 2 and put it back into that original equation. So that's negative x squared. So x is 2 plus 4 times 2 plus 1. So 2 squared is 4, but the negative sign is on the outside, so it negates the 4. Then we got 8 and 1, so that's 9 minus 4 is 5. So the vertex is 2, 5. So with the x-intercepts, that's a matter of just solving them. The quadratic is kind of one of my favorite ways to do it, unless I can easily see it's factorable. So you just realize that the number in front of the x squared is a, so that's negative 1. The number in front of the x is 4, and the c hanging off the end is 1. So there's your quadratic formula. So the negative is built in, so it's negative 4 plus or minus the square root of b squared, which is 4 squared, minus 4, again, is built in, and the a is negative 1, and then the c is just a plain old 1. So it's 16 plus 4 up there, and that gives you 20. And in the denominator, it's 2 times a, and remember, -1 was a, so that's -2 down there. All you can do is just simplify this down and approximate it, because it's always going to have a radical in no matter what you do. Even you could take it and simplify it down, but they just go ahead and approximate it. So they tell us that two x-intercepts are -0.2 and 4.2. And then the y-intercept is just put 0 in for x, just like it was on the other one. But this one's a little bit less trouble to find, because what always ends up happening is it ends up that all of these things zero out when you put the 0 in there. So all you're left with is whatever c is. In this case, it's 1. So the y-intercept is z, 0, 1. All right, and then that's what it looks like. And then if you needed another point, you can always use symmetry and go over here and get this one. All right, so the minimum and the maximum, again, the vertex is just the minimum or maximum depending on how it's laying. If it's laying like down like this, like an arch, half of McDonald's arch, then it's a minimum. If it's going the other way like this, it's a minimum. But no matter what, that x is equal to -b over 2a gives us the x value of either the minimum or the maximum. And then when you stuff it back into the function, you get the y value, the maximum value. All right, let's see. I thought they had some here. Where else? Let's find one and work it out. All right. While I'm here, I'm going to fix this for you. All right, so let me look for a something to graph. Try to do one of each. Over the textbook. And in the back of the book, they'll have something that we can look at. All right. I think I already figured out that they don't let me copy this. All right, so I'm going to import this over there on my other board, and we're just going to do everything to it. We're going to find all the points, and we're going to graph it. All right, y'all still doing okay?
Yep.
All right, so let's just going to go through this one step at a time. And the way I might like to do this is such like this. Is just label these. Let's find a vertex first. All right, so the vertex is going to be using negative b over 2a, or this is going to be the x coordinate. So this is going to be negative 2 over 2 times 1. So this is going to be 2 over 2, which is equal to 1. All right, so that's going to be our x coordinate for our vertex. Now what we got to do is find f of, and this looks kind of crazy, but this is what you're doing. I'm just trying to put it in a formula for you. So we're just going to put it in there. If y'all see me do anything crazy, just let me know. So 1 squared is 1, minus 2, minus 15. So it looks like this is negative 14, right? All right, so there's our vertex. While we're at it, let's find our x-intercepts.
It's not negative 16?
Thank you. You're right. Sorry. Brain's working backwards today. All right, so there's the first thing we got that's important, the vertex. All right, so now we want to find the x-intercepts. And we're just going to, if it's factorable, you can go ahead and do it like that. I'm not sure this one is. Just right off the bat, it might be. but I'm just going to use the quadratic formula. And remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4 AC over 2A. So negative of the negative 2 and 1 over 2 times 1. So here's going to be our x-intercept. So that's going to be 2 plus or minus 4. And then this is negative times negative. So that's plus 60, right? And it looks like to me this one would have been factorable. It might have been quicker to do it like that, but and the reason why I know it's factorable is because of it's got a perfect square in there. So 2 plus or minus 8 over 2. I can simplify this as it is right now and make it a little bit. 2 goes into 2 one time, and 2 goes into 8 4 times. So then x is equal to 1 minus 4, and x is equal to 1 plus 4. So that's 5. And then this one's negative 3. All right, so we need also the y-intercept, which is really the easy one. In this form it is. Because really it's just going to be this value of 15. But let me just go through the, so it's f of 0. So when x is 0, that's where it crosses the y-axis. So let me just put up here the x-intercepts was negative 3, comma 0, and 5, comma 0. And then the y-intercept is the opposite. It's 0, negative 15. All right, so I'm going to try to draw this one out here. And all right, now this one's got, it's got a positive x squared term. So that's going to mean that it's going like this. Yeah. I'll put these on here. And then we had, it was negative 3, 0. And then 5, comma 0. Okay. Now, I can't really draw on this, but watch what's happening. Okay, this right here is our vertex, remember? So this is a minimum point. So this thing is way up here. It's coming down, going through the y-axis, and then that reaches the vertex, turning point, and then goes back up. Okay? Any questions about those points and how we got them? So if we put that thing here, we'll see that it connects them all. We'll see, what was it? It was. See that? All right, any question about this? I want to go through one in the other form, the one in what they call this, the vertex form. I don't know that you'll deal with them too much in this class, but in Math 130, we deal with several different kinds of conic sections, which include parabolas, it includes circles, and they pretty much all kind of sort of get set up with that same kind of a thing, that same form that we looked at, and I'll show you what I'm talking about. Let's find one like it. All right, I'm going to use one, and then I'm going to change it up tiny. Well, I hate to change it because all right, we'll do this one. We're going to just find all the stuff for it. The instruction there is to say find the vertex, but we're going to do everything that we need because we can find the vertex, we can find the solutions, and we can find the y-intercept, and then we got pretty much everything we need. All right, now this one, is slightly different because it's got that negative in front. All right, so the vertex is real easy to find. Well, first of all, let's just say this one. In other words, it's like half a McDonald's arch. It's opening downward. All right, so let's just put that bit of information there. The vertex is real easy to find when it's like this because it's just this number's opposite sign, because you have to account for the fact that there's a negative in there. So the way we would look at it is x minus a minus 4. So when in the other one where it was x minus 4, then it would be only the 4 that comes down. But it's a negative 4 here. And then The 8 is the y coordinate. All right, now
you always take the opposite sign for
yeah, it's
numbers?
the opposite sign. You kind of got to look at it sort of like this. I mean,
It's for H and K.
no, just for H. In other words, let's see. So the K is exactly what the sign is. That's the vertical shift up and down Y movement. Whatever this is, it's essentially the opposite sign, because the way the standard form works, it's X minus something. So in this case, it would be X minus a minus 4 that gives us plus 4. All right.
Okay, yeah, I was having trouble with that last night.
But that's what it is. It's essentially, you can just look at it. For the X movement, it's just the opposite of whatever that number, what that sign is there. All right, now let me go back over. How did they solve these? Because I'm just going to do it my way if they didn't do something that made a little bit more sense. Yeah, see, they solved it like this. And that's fine. We'll just try that. You can do this like one of two ways, like as it is, to find the x-intercepts. Okay, so in other words, what we're going to do is we're going to solve this. And there's a couple of different ways to do it. It's all just a matter of taste, I guess you would say. All right, so the way that they should do it, like I said, is probably quicker. But what you could do is FOIL this out, then simplify by multiplying everything by -2, collecting all your like terms, and then it'll be in the form of the way this one was. And then you can put it in the quadratic formula. But it's really simpler to just go ahead and use the square root property. So then we got negative . Is equal to 8. And now I'm going to divide both sides by -2. And so this is just going to be a plain old x plus 4 squared. And it's equal to -4. All right. Now, when we take the square root of both sides, and this is probably one of the reasons why they just asked for the vertex on this one, is because this one doesn't cross the x-axis. Because you're going to end up having, you remember your, what they call the complex numbers? But we can still do it. All right. So once we got an I in there, then that essentially means it's not going to cross the x-axis. It doesn't have any solutions, because what it's doing is, it's, as I said, it's going down like half of that McDonald's arch, but it's way down here on the x-axis. So let's see something. And so let's just find the y-axis since we don't have any x-intercepts.
So if you end up with no real solutions or imaginary numbers, it
Yeah,
doesn't have
that means it's not going to
x-intercepts?
cross the axis. So let's make sure I didn't make a mistake. I tell you what, I know what I'm going to do. Like I said, there's two different ways to do it. Like I said, is we could just simplify this out. So let me just go ahead and do that. We can just double check. So right here, when we square this out using the so x squared is x squared is x squared. 4 squared is 16. And then the way we get our middle term is x times 4 times 2. So that's plus 8x. I'm just going to double check this. So then this is going to be what it would look like this. Minus 16x plus 24. And then we could divide everything by -2 to make it a little bit simpler if we want, since everything is even. So x squared plus 8x plus 12 is equal to 0. All right, let me just do something real quick over here to solve this. Right on the board is, let me just see if I can. Plus so I'm just kind of curious. All right, so like I said, everything Can you hear me better now? Okay. I just moved my little laptop because over there it was saying it was weak. All right, let me get us. Hold on a second. I want to work this one more. Like I said, that one was probably we just wanted to have the vertex on it because that's all it asked. But I wanted to see something real quick. So when it's in that form, the important thing is, I'll show you back in a minute, you want to be able to just find the vertex with that. Although you can do all of them, everything, like I did with the first one that we looked at from the book. But they've both got their drawbacks. Hold on a second. All right, just to show you this one, what I was saying about the that it came out with the imaginary things. Hold on, let me show you. What's going on with my... All I gotta do is move one little thing and then everything goes askew. What up? Okay, here's my share thing right there. All right. So just to show you, when I had those imaginary solutions that would come out down here, I didn't even have to work them out. Once I saw that I had an I in there, you can see. Hold on a second. Why is it not? Okay, there it is. It's just slow. But you see, there was a vertex, but it doesn't cross the x-axis. So whenever you do one of these and it doesn't go across, doesn't have any x-intercepts, which is entirely possible, then you're going to end up with those eyes in there. And what the eyes do, that refers to another plane, but we're not going to get into that. All right, let me find one more for us to do. Well, like I said, I just picked that one, and I should have probably picked another one because that one's got the imaginary in it. Let's see. All right, I'll just do number 23 here. Well, that doesn't really matter. All right, so the vertex is the easiest thing to find. When it's in this form, because it's just that number. If there's a negative sign there, then you just pull the number. If there's a positive sign, then you got to take the add a negative sign to your number. So that's your vertex. Let's try the y-intercept on this one. It's f of 0. All right. So we have f of 0. And then this is just going to be negative 3 squared. So that's going to be 9 plus 2, which is 11. So the y-intercept is 0, 11. Okay? Like I said, that one's pretty easy to find. It's the x-intercepts. And if I do this one, like I said, it's going to have a square root in it, and there's no problem with that. It's just so there's the vertex. Let's go ahead and just hold on a second. Let me do one more thing real quick. This one's not going to have any x-intercepts either. What do they say to do in place of x-intercepts? Hold on a second. All right, so what we can do? So we don't have any x-intercepts on this one. Because if you try to solve this one, it's going to do the same thing. Like I said, it's hard to tell when it's in this form what your x-intercepts are going to be. So, all right, so we got 11. All right, so let me just show you, because the only other thing we can do is, all right. So that's what we call the axis of symmetry right there. See, this x minus 3. So it's the opposite. So x equal 3 is the axis of symmetry. Now the vertex, as I said, is you can just get it by doing that. 3.
Can't see your screen.
Oh. I don't know what. Can't see me either because it's. All right, so this is that one we just graphed. You can see there's no x-intercepts, but I'm going to show you how to find another point. But anyway, x equal to 3 is the axis of the axis of symmetry. Now, what did we say? We had 11. So this right here is your y-intercept. So this right here was your vertex. this right here, 0, comma 11 is the y-intercept. So let me show you how to find another point. Because it might say graph at least 3 points. All right, so since this is the axis of symmetry, then over here to this point right there is also still on the y-axis of 11. And then when we go over there, though, we're no longer at 0 because we're going 1, 2, 3 to get to the axis of symmetry. And then after that, we got 1, 2, 3 to get to another point over there that's symmetric. Because remember, that's what's symmetric. But no x-intercepts on this one. Again, the reason being is if it started down here and then was going up, it would cross the x-intercept. Now, one of the things that I used to kind of do is, let's see something. Let's just say we were to go down and flip it. See, that's that symmetry we were talking about with respect to the x there. So I'm going to take it off, and I'm going to show you one more little thing. Just it's kind of the book doesn't show you, but let's just kind of look at it. Let's set that equal to 0. So if these right here are real easy to solve using what's called the square root principle to get them, but sometimes it could be a pain in that because like I said, it's hard to say. See, because that -2 is over there, when we take the square root, we're going to end up with the irrational, the imaginary roots. So that's going to be x minus 3 is equal to plus or minus I square roots of 2. And we can solve it, but like I said, we can't really put it together because some of these are just not going to have x-intercepts. You have all the rest of the things. You'll still have a vertex. You'll still have a y-intercept, but you won't have the x crossing. So let's see something. Let me just try one thing real quick and see if this is something that might be helpful. If it did cross at that point, then there's a way to use this because it would be 3 plus the square root of 2. The square root of 2 is 1 point, it's like 1.3. So that's one of them. I mean, it can give you an idea of where they would if you could transpose it downward. Remember, this one wasn't transposed downward, but anyway, if we did, then there's the square roots we would have. All right, well, I didn't get quite as much what I wanted to go over, but it's getting back into this office and everything being different, you know? It's a pain in the neck. This stuff doesn't work over here like it does. All right, so if you got any questions, stick around. Who was it that is Savannah out there? I didn't see Savannah. Tranisha, I didn't see. Bretland, I didn't see. Lauren, I didn't see. Taylor, I didn't see. All right, so that's everybody else I got. All right, well, if you got any questions, just stick around. I'm here.
I have a question when you get a minute.
Mm-hmm. Go
So
ahead.
when you were looking for the y-intercept and you put f of 0, where did you get the 0 from?
All right, let's go back and look at the graph here. By definition, when a graph, it doesn't have to be a parabola, it could be a straight line. When it crosses the the y-axis, x is 0 at that point, see? See, there's the y-axis right, the y-intercept right there. So it crosses at 11, and at that point, that's where x is 0. So that's how we find the y-intercept. It's also how we find the x-intercept. So let's just say we did this one, because I already know a little bit about it. So the opposite is true here. See, at this point here, that's when y is 0. Now, with a parabola, you got two solutions. So when you set the whole equation equal to 0 and solve it, then that's when you get your two x-intercepts. And it both of those because y is equal to 0. And as I had said too, like for this one's going to go down here. It crosses at 7. And see, at that point, that's when x is 0. So that's how we find the y-intercept, is to put in 0 for x and whatever's left over. Now, as I had said, if it's in this form here, like in this squared form here, then that right there is going to be your y-intercept, that number hanging off the end. And then the x-intercept, of course, you got to solve it one way or the other. Like this one, since it was already in the ax plus b, ax squared plus bx plus c, I just popped the numbers into the quadratic formula, and that gave me the two solutions. So that's the way it works. It's just when it crosses the y-axis, any graph, x at that point is 0.
So in other words, in order to be a function, it has to cross the y-axis one time.
Well, that's true, yeah. We can't have multiple crossings on the y-axis of a function. You remember when we looked at one, like if it was, see, like this one's not a function. So this one right here is not a function. See, it's got, well, let's just say we back up a bit. This one's only got one y-axis, but I was trying to show you. So see that? Oops. And I was trying to make one that crossed and the y-axis more than once, but there we go. See, that one crosses twice, but this is not a function because it's got the y squared. The functions, the quadratics, are always going to be y is equal to x something squared something. So you can have multiple x crossings, with nothing wrong with that. You can have no x crossings, depending on where you're at. But what you will never have is more than one y crossing on a function. All right.
Got it. Thank you.
All right. So tomorrow we look at the other kind of fun. I'm not sorry, tomorrow, Wednesday, the other kind of functions. All right. Well, I'll see y'all next time.